Objects placed in a liquid feel lighter when in the liquid than when outside the liquid. For instance, you may notice that it is difficult for anyone to push or pull a boat or canoe on the dry shore, but as soon as it gets on water, the canoe moves easily. Also, if you were playing football and your ball fell in the water and you tried to get it, even if you mistakenly pushed your football on the water, you would notice that it keeps going back up. It feels like there's a force pushing this ball out of the liquid. The principle behind this phenomenon is called the Archimedes Principle, and it's named after the Greek scientist who first observed it. Now, what does Archimedes' principle state? It says when a body is fully or partially immersed in a liquid, it experiences an upthrust equal to the weight of the liquid displaced. Another word for upthrust is buoyant force. This force is always acting upward at the center of mass of the displaced liquid. Now let us prove this using an experiment. All we need is an object like a stone or metal or a cork that can be hung from a string and attached to a spring balance. The reading on the scale can be noted as F1. Next, we fill a displacement beaker with water and drop the object to fall freely into the liquid. Place the small bowl on a scale under the spout of the beaker. The reading of the weight on the spring balance is noted, and then we carefully drop the object into the water, and you will notice two things happen. First, the water in the displacement beaker will spill over and be collected in a bowl. The second is that there will be a force on the spring balance. The initial force will start reducing until the object stops sinking. The final reading on the spring balance when the object stops is F2. The water that was displaced into the bowl can be weighed, and the value will be equal to the difference in the force on the spring balance, which is F1 minus F2. So the weight is equal to F1 minus F2. Now notice that the object was moving downward under its weight and then stopped sinking. This means that there must be a force opposing the weight or the sinking force of the object. And this force is what we call buoyant force or upthrust. This force acting on the object will always be equal to the weight of the displaced water. There's another way to write this equation. Notice that the initial force, F1, applied on the spring balance is equal to the weight of the object. F1 is considered the real weight of the object. Now the force F2 is the weight of the object when placed in the liquid, and this is the result of the difference between the real weight and the upthrust. So this force F2 is referred to as apparent weight. This means that we can rewrite our equation for Archimedes' principle as the weight of the displaced liquid is equal to the real weight of the object minus the apparent weight of the object when placed in the liquid. And that is the core of Archimedes' principle. It states that whenever an object is placed in a liquid, it will experience an upward force that is equal to the weight of the volume of the liquid displaced. So let's discuss the implication of this principle in further lessons. Bye for now.